All right. Here are three examples. We will use the law of sines for each of these, but I'm going to use these to demonstrate how if we run into an example of, and I cut my last video short to create a unique video for this, but if you draw out the triangle and you run into that angle side side, right, there is a potential problem. You could get information that is impossible to draw a triangle. You could get information that could create one triangle, or even more strange, you could get information that would end up having two possible triangles with what is given. So I always recommend drawing a visual no matter how the problem looks. Okay, and if you get this, double check. So let's get going. The first one, again, any drawing will do. Too often we get stuck drawing kind of random, like this kind of triangle or a right triangle, right? That's okay. But if you have an obvious obtuse angle on there greater than 90, I would at least draw that. It kind of helps you visualize a bit better what's going on. So 119, that angle somewhere around there, right? So there's alpha, 119. Then across from alpha would be lowercase a, which is 14. And then we have lowercase b, which it doesn't matter which side you choose. We'll just choose this one for b, which would mean this angle here is beta. Now remember, if you don't like the Greeks, just the Greek letters, that is, change it to capital A. That's fine. Okay, capital B for beta. And then gamma is here, or capital C, and therefore this lowercase c. Okay. So we have lowercase b. I didn't write that. I just wrote lowercase b. This side is 26, right? So I have capital A, lowercase a. I don't know beta, capital B, but I do know lowercase beta. So I know 3 of the 4 all contain within the A's and B's. So that's what we're going to use, right? Remember, law of sines, it doesn't matter if you choose to do the angle up top or the side in the numerator, right? We could do reciprocals of these, it still works. So I don't know the angle beta though, so I'm going to use the way that I wrote it there. So let's set this up. Sine of A, or sine of alpha, right, sine of 119 degrees over 14, that's lowercase a, equals sine, since this is in Greek, so I'm going to stick with Greek, sine beta over b, 26. So I don't know sine beta, so we multiply by 26 on both sides. And now you can see like why I chose to leave this on the numerator, right? Just easier to solve. So sine beta, and then I need a calculator to do 26 over 14 times sine of 119. Make sure you're in degrees still. Most of these law of sines and cosines are typically in degrees. So you get about 1.6 something. So sine beta is approximately 1.6 something. I'm just rounding. No matter what, even before I use my calculator on this problem, I could see there's something wrong. And the reasoning is sine of any given angle is always between -1 and 1, right? And right here, I'm multiplying by 26 over 14, which is 1 point something, right? 26 over 14 is 1 point something. So I'm going to get some number less than 1 multiplied by this. And this is, in fact, this almost 2. I guess I would need a calculator just to make sure, but my guess is I'm going to be outside the range. So remember, sine cannot be 1.6. This is impossible. And even if you forget, how do you finish this, right? You do sine inverse in your calculator of the 1.6, whatever that result is. Don't round, by the way. Try to get as accurate as you can for these. But, you know, that number there, and you'll get an error. You can't do that. So there's a problem with this one. Now, if I go back and look at my drawing, it almost seems there's a problem, right? Because if this is the obtuse angle here, I know the other two have to be less than 90. In fact, there's some, because they add up to 180, right? All three of them. The sum between angle beta and gamma has to be 61. So I know they're relatively small angles. It's impossible that such a small angle for beta would have a larger side of 26 than the side opposite of the obtuse angle. In a triangle, the larger angle, the side across from that will be the largest side. Okay, the largest angle goes with the largest side, smallest angle, smallest side. And that makes sense. Like, draw any triangle, right? The smaller the side, the smaller the angle, the smaller the side. And the smaller the side, the smaller the angle opposite. But I don't trust my art ever, so I would never fully go off of the drawing that I provided. In this case, I mean, it does make sense, but mathematically as well, I'd shown, right, we don't get an answer, we get something impossible. So this first example, in fact, cannot make a triangle. Okay, so no triangle possible. Okay, let's move on to the next example. All right, gamma is 80. So again, I'm going to try to draw somewhat relevant. I don't know, gamma 80, not quite a 90. We'll leave gamma up here. It really doesn't matter though. This one may not be to scale at all. Okay, we're going to call that 80. And opposite gamma is angle, or side C, which is 5.3. And then we'll just stick with this still being beta. As an opposite beta is 3.5. So therefore, this is alpha, and opposite alpha is A. Okay. So do we have enough to get going? Yes, we have little c, big C, right? Gamma. And then little b. So therefore, I know I need to set it up not knowing sine B. So we have sine beta over little b, right? This is b, 3.5, equals sine gamma 80 over 5.3 little c. Okay, solve for sine b, sine beta. We multiply by 3.5, so 3.5 over 5.3 times sine 80 degrees. And then, so I don't have all my calculator work handy, but whatever you get here, you'll do sine inverse. Okay, so you'll want to plug that in the calculator and then hit sine inverse to get beta. We'll use approximately. Get approximately, what, 40.6 degrees? Okay. Now here's, if you get an answer with ASS, here's one thing you have to check. We have to check, is there another possible triangle? And in this example, the answer is no. But how do we know that? Here's the idea. I'm going to draw a random angle up here, up in quadrant 1. Okay, when I do sine inverse, and I get something up here in quadrant 1, we'll just stick with like the 30-degree angle, for instance. Okay, and it tells me that I get 30 as my angle. Then, because sine is the y value, right, another possible angle is over here then with that same y value, which I know that that angle is 150. Now, how do I know that? Because as 30 is the reference angle, right? So what did we do? We did 180 minus 30. So when you check these, I have to check, is 180 minus 40.6 another possible angle? Well, that would be about 139.4 degrees. And because gamma was 80, that's impossible, right? We don't even have alpha. We don't even have our third angle. And I know that I'm greater than 180 just summing those two angles. So in this case, it doesn't work. Therefore, I'm only one possible triangle. Okay, I can only get one. And it has to be, beta has to be 40.6. Okay, now how can we proceed? Well, let's do the next angle, right? Because we know two angles, gamma and beta. So alpha is easy because we just do 180 minus the sum of beta plus gamma, right? Minus 120.6 to see what's left over. Now I'm going to do approximate because we did round beta, so I'm technically rounding alpha. And you get what, 59.4. Okay, so now I know this beta was 40.6. And then this one, I'm out of room, so right over here, 59.4. So last we need the side alpha. I'm sorry, the side A, side opposite of alpha. Okay, I was given 3 pieces of information, 2 sides and an angle. Now I have the other 2 angles, right? So I need the last side. So we need lowercase a, and therefore I'm going to do the law of sines, but with a up top. Okay, sine alpha, which was 59.4, equals lowercase b, which is 3.5 over beta, 40.6. You know, it shouldn't matter, but because we did round for beta, I'm going to take a step back. It's always best to use, in my opinion, the original information. Use C, which is 5.3, and use gamma, because we didn't round at all for those, right? Those were values that were given to us. So I know my answer would be better by using that. So now multiply this sine 59.4 on both sides of the equation to isolate A. Okay, and then, well, now this is all calculator work here. Right? As long as it's input correctly, you should get about 4.6. One thing to note with many problems of this is it's unitless, which is really weird, right? I don't know if the sides are in inches, centimeters, miles, kilometers, who knows? So I'm just saying little a is 4.6, I mean whatever unit they choose. Well, the first one, there was no triangle possible. Second one triangle possible, and we got all 3 pieces of missing information. And so therefore the third one, odds are we're going to get 2. So let's check that out. I'm going to slide this over just a tad. And I'm going to draw this one like this for so I could demonstrate how 2 could be possible. Okay, I'm going to do beta here, 24 degrees. And then we'll just do gamma here, so this lowercase c, and we'll do capital A here, and this is 7. Okay, and this is 3, lowercase b. All right, So we didn't do any math yet. We will show that two cases are possible, but I wanted to show as well, like, how could I draw the information given? How is it even possible to draw two? Well, picture this 7. I know I need to keep this 24 degrees, right? So visualizing, there's something 24, and then I kept this as 7. The only other thing given is the fact that this lowercase b is 3. Well, suppose I took that and I swung it out this way instead, right? So I'm going to draw 3 like this. I never knew lowercase c, right? I never knew gamma, and I never knew capital A. Sticking with only what was given, this, 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 and I know I freehanded it, but it looks pretty close, right? And that angle, just that angle, right? Definitely seems like 2 could be possible. So now let's show, using the law of sines, that it is in fact possible here. Okay. Without a picture, I know I had A, B, and B, right? Little b, big B. So therefore I knew I didn't know sine capital A or alpha over 7 equals sine beta, sine 24 over 3. Okay, sine A over A, sine B over B. And we solve for sine alpha. So we multiply both sides by 7. So 7 over 3 times sine of 24 degrees. Okay. And because sine of 24 is fairly small angle, that will yield alpha is approximately, now, sorry, describing it without, like, I don't have a calculator on the screen, right? So the last step, we do need to do sine inverse of whatever we got for that. Let's stick with blue. Okay, now substitute that in the calculator, and you should get 71.6 approximately. All right. Now, just like the other one, what do we have to do is check 180, subtract that. Would it give me another possible angle? Okay, so we'll just say this is, well, alpha's fine. So another possible angle, and most textbooks do a prime, alpha prime, is 180 minus 71.6, and we get, what, 108.4? Alpha prime is approximately 108.4. And then we check, could that work? Well, if beta is 24, then we could definitely still find gamma, right? Gamma would just be 180 minus 108.4, oops, minus 108.4, and then minus the 24, right? Minus alpha and beta. And then that gives us, since we rounded the 108.4, that gives us 47.6, right? It is possible then that beta, with only given information beta is 24, that alpha is 108.4 and gamma is 47.6. So I'm going to say or here, because originally I found alpha to be 71.6, which would make gamma, what, 180 minus 71.6 minus 24. So that would make gamma approximately 84.8. 84. 20. Sorry, doing math in my head. Minus 24. 84.4. Yes, that looks right. Okay. Sorry, I should have had that prepared. Anyways, those are our two possibilities. And remember that neither one of mine are necessarily drawn to scale, right? I'm drawing a picture in there to help us visualize what could be possible, but it doesn't mean that my drawing is great. Okay. So regardless, in both of these now, I'm just missing side C, little c. So we're going to use, again, I think it's best to stick with the original information. So I don't know little c over sine gamma 84.4 equals little b over sine beta. Okay, so I'm using the little b and beta because both of those things were given to us at the start. If I used sine alpha, right, that I did approximate on that one. Okay, multiply both sides by that sine of 84.4. And again, much of this is just all calculator work, but you'll get about 7.3 it looks like. And then on the right hand one, set it up the same way. C over sine gamma, 47.6 equals B over B sine 24. Calculator, and you'll get approximately 5.5.